Hello, everyone, and welcome to this ninth episode of my publication at a glance. Today, we welcome Dr. Gwenaelle Jezequel, who is currently a postdoc at the CNRS at the EPBS lab in Toulouse. She did her PhD and a postdoc at the CNRS at the ICSN in Gif-sur-Yvette, and then did a postdoc at the Helmholtz Institute in Saarbrücken. And today, she will share her results on macarangeline B. Gwenaelle, the floor is yours.
Thank you very much. So indeed, I'm going to talk to you about our publication that is entitled Minimalist Nature of Filling Macarangeline B, Delineates OSBP Biological Function. That was published in Jezequel, and as you can see, it's a highly collaborative work. This project originated from the discovery of macarangeline B that was isolated from an extract of Macaranga ternaeus thanks to our Vietnamese collaborator. And what was interesting to us is that this molecule displayed an hexahydroxanthine moiety similar to the one of Schwann-Fertin-G. And Schwann-Fertin-G is a part of a bigger family of compounds that is called natural off-fillings. It's all natural molecules that have in common to inhibit OSBP, which is a protein responsible for the intracellular transport of cholesterol between the endoplasmic reticulum and the Golgi apparatus. So we wanted to check if macarangeline B also had this property, and we checked it with a FRET assay measuring OSBP-mediated cell transfer inhibition, and we could show that indeed natural macarangeline B could inhibit this cell transfer in a dose-dependent manner. But what was interesting to us was also that macarangeline B was isolated as a racemate, which is very rare for natural compound. And then to study it further, we set ourselves to perform the total synthesis of both enantiomers of macarangeline B. So we managed to achieve it in 7 steps, including especially a Suzuki-Miura coupling to obtain the geranyl chain here, and then the sharpless dehydroxylation to introduce the stereochemistry. And then a key step is the cascade cyclization induced by Lewis acid to obtain this hexahydroxanthine moiety. And thus we retrieve the R compounds, and in similar fashion, with only changing the catalyst of the sharpless dehydroxylation, we could obtain the S compound. Then we tested both enantiomers for the binding to SBP by FRET measurements to locate the determination. So we could show that the R compound actually was a lot more, was a way better binder of OSBP compared to the S compound, and it has a similar KD to Schwann-Fertin-G. So what was interesting is that we could show that stereochemistry plays a significant impact on OSBP binding. And then we try to rationalize the binding mode using molecular dynamic undocking. So we could show that for the R compound, there could be like 2 possible positions, the up position and down position, whereas for the S compound, there was only the down position that seemed possible. And the compounds display essential interaction with the lysine and the phenylalanine of OSBP. What was also very interesting with macarangeline B is that it is autofluorescence, which means that we can do direct imaging in the cell with no chemical modification, which is of course very interesting to study the mode of action. So we could show that the compounds colocalize clearly with the OSBP M cherry at the Golgi network. And we could also show that there was a competition with OSW1, which is a better binder of OSBP. And then we could see that in presence of OSW1, we didn't have this accumulation at the Golgi of the compound. Then we also wanted to verify our hypothesis about the binding mode that we got from the molecular dynamic. And with the point mutation of OSBP on the 2 amino acids that were involved in the binding, meaning the lysine and the phenylalanine. And we could show that when we did point mutation of this amino acid, there was not the recruitment of the compounds at the Golgi. So this confirmed the predicted binding mode and the mode of action. Finally, we wanted to do a biological evaluation of the compounds because what is very interesting with the off-fillings is that despite their very different scaffold, they all have a similar cytotoxicity profile on the NCI cancerous cell line panel. But macarangeline was actually the first one to show different profile and a lower toxicity. So for the first time, we could observe a decorrelation between cytotoxicity and OSBP affinity, which is a tremendous advantage for antiviral application, in particular against the Zika virus, for which the intracellular transport of cholesterol is essential. So we tested our compounds on the Zika viral particles production, and we could show that in the presence of macrolide B, for example, in the presence of 200 nanomolar, we had a 2-log reduction of the viral particles production. We can see a slight difference between the two enantiomers, and we can see that the R enantiomer is as active as the Schwann13G, but less cytotoxic, hence its interest. In summary, we discovered a novel natural compound scaffold that presents strong OSBP affinity and an autofluorescence that allows us to understand better the mode of action. The compound also showed unexpected cytotoxicity, which allows antiviral application against Zika virus. If you want to learn more about this, don't hesitate to read our paper in Jezequel. Thank you very much.
Thank you very much, Gwenaelle, for sharing these results and this great presentation. To anyone watching this video, if you are interested in sharing, showcasing your work under that format, do not hesitate to contact us. You have all the link and info you need on that slide. Thank you and see you next time. Bye.